All right, so I wanted to look at the conceptual exams. This is the one that's probably in the lower, I think it's in the lower right-hand corner. And what it asks about is it asks about these trains. So there's an observer outside the train, and he is looking at the person moving and the train moving. So they want to know how to rank them so that you get the greatest speed first, I think is what it says. So let's make sure that I'm telling you the truth. Yeah, all right. So I'm going to say that this is going to be my 16. I'm looking at the magnitude, 20. This one looks like it is 16. This one looks like it is 32. This one looks like it is 20. And this one looks like it is 24. So I'm going to say that I wanted the greatest first, so I'm going to have D, which is greater than, looks like F is next, which is greater than E and B, which are equal to each other, which is greater than A and C, which are equal to each other. So that one was not too tough. All right, I'm going to pause and pull up the next one. So this one asked me to rank them in terms of the greatest average speed, not velocity, so I don't pay any attention to the direction, I just do the average speed. Well, this average speed is 0. This one is also 0. This one is 10 by 10, which is 1 meter per second. This one is 3 over 10. So that's 0.3. This one is 30 over 10, which divides out to be 3. This one, I called this 7 right here. So 7 plus 7 is 14. So that one's 1.4. So when I ranked these, I didn't pay attention to the sign. I said that E was the greatest, and it was greater than, looks like F, which was greater than C, which was greater than D, and that was greater than A and B, which were equal to each other. So that one wasn't too bad. Just pay attention to the fact that it said speed. All right, this one said to rank in terms of greatest height, I believe. So if I look at that, these masses don't mean anything because gravity is going to pull the same on all of them with the same 9.8 meters per second squared acceleration. So I said, well, let me think about this. The greatest height achieved is going to be one that's moving the fastest because it's got the most speed to get rid of. So I said, well, it looks like to me this one is at 40. This one is at 40. So they're going to move the greatest height. And then I went to the 30 and the 30 and the 30, and I said that A and E and G were equal to each other. And then finally I said that H and C and D would be equal to each other, but less than BF or EAG. So let me do the last. Alright, this one asks you to look at the change in velocity of the cars. So I said, well, this one changes its velocity by 10. Alright, I need a pen. Sorry about that. By 10. This one changed its velocity by 10. This one changed its velocity by 10. I'm going to make it negative because it slowed down. This one had a negative 10 change. Let's see if we can look at the last of these. Not very well, so hang on a minute. Alright, so it looks like I have to do them again. No big deal. Oops, still can't see H. Hang on. Alright, so 10, 10, negative 10, negative 10. Went from 10 to a negative 10, so that's going to be a negative 20 change. Went from negative 10 to negative 20, so that's a negative 10 change. Went from 20 to 20, so that was no change. I went from positive 30 to negative 20, so that's a negative 50. So if I rank them in the greatest change in speed first, I know that A and E are equal, and they're the most positive, so I'm going to say A and E are equal. And that value is greater than my next one, which is D, because that's 0, which is greater than B and F, which are equal, which is greater than, and then I had G. I'm sorry, I should have had an equal sign right there, because G is equal to those other little rascals. Alright, so I got that one, and then I needed a negative 20 and a negative 50, so that would be C, which is greater than H. So if I didn't skip any, I think we're good to go. So I said that A was equal to E, which is greater than D, B, F, and G are all equal, C, and H. Okay, so we'll stop there and look at a few word problems. Alright, I'm going to look at number 1, because some folks had trouble with that. Here I am, I'm the loser in the race. Here's the winner. He outruns me by that distance right there. So that's going to be his average speed times the time that he beat me by. So his average speed is 1,609 meters. And he ran it, okay, so his time was 46. Yeah, 46. So that's 180 seconds plus another 52.46 seconds. So his time was 232.46 seconds. So there's his average speed. The other guy was 352.72, I think. So I'm going to say 0.72 works for me. So that difference was 0.26 seconds. So I was beaten by 0.26 seconds. So I was outrun by about 1.8 meters. Alright, then I want to show you number 6. Number 6 says that you have a Ford Mustang that starts from rest. So VI is 0. Has an acceleration during this time period of 3 meters per second squared. And that lasts for some time that I'm going to call T1. And then for T2, the second stage of this motion, which is equal to T1, he had, I need to give a final speed here. His speed after this situation here, I'm going to call X. So then time 2 begins, and the initial speed of time 2 is X, because it's the final speed that he ended time 1 with. I have no idea what his acceleration is. That's what they're asking me to find. And I know that his final speed, the problem tells me, is 2.5 times his final speed at the end of the 3 meter per second squared acceleration period. So if the times are equal, then VF minus VI over A1 has to equal VF minus VI over A2. Where did I get that equation? VF equals VI plus AT. So I rearranged it and solved for T, so VF minus VI is AT. So there we go. So VF was X minus 0 over 3. Has to equal, 2.5x minus x over A2. So if I do the algebra, I get x over 3 equals 1.5 x over A2. The x's will cancel. And if I cross multiply, acceleration 2 is simply 3 times 1.5. And I am good to go. So my acceleration is 4.5 meters per second squared. Alright, let's see. 7 was a quadratic, and I promised you I wouldn't give you any of those. I'm going to do the tuber, and then I think I'm going to be done. 8 is the bridge and the tuber. Very similar to the one we did where the ball or whatever it was went up and came down, except this is a lot easier. The speed that the tuber, the friend on the bridge releases the object with is 0 meters per second. It's got to fall 75 meters. And the acceleration is a positive 9.8 meters per second squared. So I can find the time that it falls. And the time that it falls is equal to the time the tuber has to get over there and catch it. So I'm going to say that d equals 1/2 at squared plus bit. This is 0. So 75 meters is equal to 1/2. A is a positive 9.8. So I can find the time that it falls for. And I believe when I did it, let me see if I can find my answer, my work. I'm going to pause and find my answer, and then I'll come. Okay, so that becomes 3.91 seconds. And this person in the water is going to go some distance. And that's what they're asking me to find. So his average speed, because he does float and he's not accelerating, time his time gives you the distance. So his average speed is 5 meters per second. And he has 3.91 seconds to get there. So the distance he travels is going to be 19.6 meters. Study and be ready to go, please.